Hi guys, just wanted to give an update on the Humidor temperature control project. So I have here an Arduino board. This was my original plan, is to use the Arduino. I have a 4-channel relay board and an LED display, and also in the cabinet I have some thermocouples to monitor temperature. But the more I thought about it, I realized I can have this control both temperature and humidity. I could have it monitor temperature and humidity in multiple locations. I can have it record trends and output that to the computer. I could have it monitor the water level and tell me if the water level is getting low. So there's just a lot more that I could do with this, and I realized that this is going to end up being a larger project. So I still have to learn. I've started learning the Arduino language. It's not terribly difficult, but I just realized that it was going to be a lot more mapping out of everything I want this to do. So that's going to actually turn into a bigger project in and of itself. So I decided to set that aside. Um, I had this controller. Now this is a temperature controller. It will activate both heating and cooling. It's a PID controller, a proportional integral derivative, and what that means is it uses what used to be called fuzzy logic. So that, for example, if the temperature, if you were trying to heat up something to 200 degrees and you're at room temperature, this would fire on the heat full blast, and then the closer it gets to temperature, it would start to pull back on the heating to try to minimize the overshoot. And so then after that, it basically controls the power proportional to what's needed to keep the temperature stable. So this is a fairly sophisticated board from that perspective. It's not just on off like a relay switch would be. And so the other thing too, quite honestly, is so I decided not to use this, and that's one reason. The other reason, quite honestly, is because it's so deep. So I had made the decision that I want to put the temperature and the humidity displays inside the cabinet so that I could see them and get to them if I want to. But this is just physically, it's too deep. And so the next option is this controller here. And now this one actually looks identical to the humidity controller, but this is a temperature controller. It activates both heating and cooling. And the way it works is it's got hookups for power supply, the temperature sensor, which comes with it right here, and then one relay for heating and one relay for cooling. And I bought this off of eBay for 17 bucks. So, and quite honestly, if you're willing to do an auction, I did buy it now, but if you're willing to do an auction, you can probably get them for like 10 or 15 bucks. I mean, I really don't understand how these guys make any money. Like I said, the humidity controller, which, like I say, looks identical to this that I purchased off of eBay. I spent $40 on it, and I think now they're around the $20 range, so, or less, maybe 17, 18 bucks. So you can really get this stuff really, really cheap. Now I have other parts on order. I have a thermoelectric cooler on order that hasn't come in yet. I expect it to be here, another couple of weeks. Other than that, I have these fans. And so here I'm going to admit to some ignorance in the evolution of computer fans. I didn't realize that everybody was basically using brushless fans. And so the thing about these is that they have a circuit board in here to monitor the position of the rotors and control the magnets. And so you can't reverse this fan. And so my plan is, I have two fans, and the cabinet is two separate cabinets with a partition in the middle, and I'm going to be cutting some holes. And the idea is to have one fan draw up the air through the cabinet where the humidifier is, so it's going to be pulling up the humidity, going up through the plenum where the temperature, the thermoelectric cooler is going to be to affect temperature, and then blowing down into the other cabinet and basically circulating the air through the two cabinets. Now, so I had wanted to reverse one of these, and I can't do that. Now I know, the obvious thing is to, flip the fan over, but these were purchased specifically so that they would drop into an existing hole. And so if I flip this over, obviously it's not going to drop into the hole, and I have a height constraint here on both sides. So I think what I'm going to try here is I'm going to just cut the fan off. It's held on to by these four little arms here. So I'm just going to cut these along the wall and flip the motor around and then epoxy it back in place with some high temperature epoxy. I've got several in the cabinet. Anyway, so that's kind of the plan. If it doesn't work out, it was $3, so it's not going to break the bank. But right now that's the plan, is to use this controller, and I have a schematic that I just want to go over real quick. So this is a schematic, and I just wanted to go over this real quick in case anybody watching this thinks it's stupid and has an idea that they can offer. But and I don't have a pointer, unfortunately, to show on this. I'm a noob on this. But basically, the way a thermoelectric cooler works is that when you forward bias it, one side gets cold and the other side gets hot. And so you're basically transferring temperature from one side to the other. When you reverse the polarity, when you reverse bias it, then the side that was getting cold will now get hot, and the side that was getting hot will now get cold. So basically that allows you to use one side for heating or cooling. And so the way this is set up, in the upper left hand corner there's a DC power supply, and you see S1 and S2. Those are the two switches that are in the controller that I just went over. So basically when S1 gets triggered, that's the cooling, and so what will happen is that will power up a relay, and the relay will, which is labeled up there as relay 3, will close and drive the thermoelectric cooler, and also at the same time it'll drive another relay which will kick on all the fans. Now once that's reached temperature, then of course all the relays will open up and the fans will shut off, and the thermoelectric cooler will stop cooling. If the heat gets triggered, then relay switch 2 will close, which will activate relay 1, and that will actually supply power to the thermoelectric cooler in reverse, and that will cause it to heat. It will also turn on all the fans. So and then separately down at the bottom, speaker 1 is the humidifier. I couldn't find a schematic symbol for a humidifier, but the AC drives the humidifier and an AC fan, and when that kicks on, it'll kick on a separate DC power supply that will also turn on the fan. So basically I'm running it this way so that excuse me, that the nothing gets powered backwards through the circuit. So I'm not shorting anything or running anything in parallel. That's why I have all these relays opening up. So, but anyway, that's the update. And when I get the thermoelectric cooler, I'll probably start breadboarding all of this. Anyway, thanks.